Euclidean on the beat.
Hello everyone, on this video I'm going to show you how to calculate the shaded area. Like they'll give you a shape like this one and then they ask you to calculate the shaded area. So they're actually asking you to calculate over there. So these questions are quite different. In maths, there is not one way of doing a particular question. So I'm going to show you one way of dealing with this one, and then I'm going to do another question where we are dealing with it totally different. So what you're supposed to do is to think of how can I solve this problem. When you look at this one, you have two shapes. You have a triangle there that is not shaded and it's on top of a semicircle. So you have a semicircle and you have a triangle. So when you calculate the area of the semicircle and subtract the area of the triangle, you'll get that shaded part there. So this is one kind of a question that you may have. In this shape, you have two shapes. In this figure, you have two shapes. You have a semicircle and a triangle. So with this triangle, there are two lines that are forming a 90 degrees. This one is your height and that one is your base. So the area of a triangle is half base times height. So you're going to multiply that and that. You can choose. You can start calculating the circle or you can start calculating the triangle. I choose to start with the triangle. So the formula of the area of a triangle, I'm going to call it area 1 because I have two areas. It's half times base times height. So it's half times my base is 5 centimeter and my height is 12 centimeter. Then you take your calculator, you calculate. Half is the same as 0.5 times 5 times 12. Let's calculate that. Right, the area of the triangle is 30 and the units that they've given to you, it's centimeters. So it's 30 centimeter squared. So when you're calculating the area, your units will be centimeters squared. Now we need to calculate the area of the circle, semicircle. But now when you look at the semicircle, we don't have, they didn't give us the diameter. We don't have it. So you have to calculate that first. We are going to use the triangle because this is a right angle triangle. They've given us a right angle triangle. Then we can use Pythagoras to calculate the side. So we're going to start with that. We're going to call it diameter. We're going to call it diameter squared is equals to 12 squared plus 5 squared, and it's Pythagoras. You need to write the reason why to do that. Because they didn't give us the AB, what, you can just write it straight like that. The diameter, when you look at it, is the hypotenuse. Always when you're using Pythagoras, that line that is opposite the right angle squared is equals to the sum, meaning that you add the other two lines squared. So diameter squared is equals to 12 squared is 144, 5 squared is 25, and when you add this is 169. But notice here, most learners make a mistake here. This is not the answer. This is diameter squared, is not the diameter. Diameter squared is 169. So I need to get rid of the square by putting a square root both sides. So my diameter is going to be 13 centimeter. So I got the diameter. That line there, the diameter is 13 centimeter. Right, now I'm calculating the area. I'm going to call it area 2. The area of the semicircle. The area of the semicircle, the formula for the area of the circle, it's pi r squared. But because it is half the circle, it's semicircle, I divide it by 2. In our question, we just calculated the diameter. The diameter is not the radius. The diameter is the whole line. So radius is half of that. So I need, and my formula does not have the diameter, it has a radius. I need to find the radius first. The radius is the diameter divided by 2. The diameter is 13. So that 13 I divided by 2. Then I get that my diameter is 6.5 centimeters. Then I can put it in my formula, area 2. Pi is a number from a calculator. You don't have to worry about it. In the question paper, if they want you to use a particular number, 3.14 or 3.1 something, they will tell you. If they don't tell you, you'll punch it in your calculator. I'll show you how you punch it. And then my diameter is 6.5. And then you remember the radius is 6.5, but it was squared. So you need to put the square there. And then because it's semicircle, not a full circle, divide by 2. Then I can find the area 2. The area 2 is the area of the semicircle. Right? With different calculators, it differs. With this sharp calculator, the pi is there. So you say pi, you say times 6.5 squared, and then you say equals to, then you divide everything by 2. Divide by 2 equals to, then I make it to decimal. I'm going to round it to 2 decimal place. It's 60.38. So my area 2 is 60.38, and then the unit is centimeter squared. Now, how do I find the shaded area? The shaded area. Let's look at the diagram again. The shaded area, do you see, is the semicircle, is the area of the semicircle minus the area of a triangle. The triangle was not shaded. So the shaded area, I'm going to write the area of the semicircle, and then I subtract the area of the triangle. The area of the semicircle is 60.38 minus the area of a triangle. This is the area of the semicircle minus the area of a triangle, which is 30 centimeters. Then 60.38 minus 30. Then the shaded area is 30.38 centimeter squared. This is how you calculate it. You calculate the shaded area. Okay, this is our second example. It's done totally different from the way that we did the first one. So in maths, when you get your question paper, maths question paper, don't go like the shaded area, we do it like this. No, read that particular question and see what you are given and see how to calculate on that particular question. That's why mathematics is an important subject. It's a subject that teaches you how to solve problems. So we can't say we're teaching you how to solve problems when we have solved the problem for you already. So you are going to get different problems and use your mathematical knowledge to solve them. So let's look at this one. It's done totally different from the first example. Here they say Wally wants to construct a ramp EF. So this is the ramp that he wants to construct. From the top of the staircase E, from there to the ground F, at the clock tower entrance of the school. So this ramp is 1.3 meters long. So here they are telling us that EF is equal to 1.3. So EF is the ramp, it's 1.3. DE is equals to, let's find DE. DE is that line here. After you've upped the ramp going that way, DE is equals to AH. AH is equals to that one, that line there. AH, and is equals to 0.2 meters. They've given it to us. And then they've given us GF is equals to 1 meter. Let's find GF. GF here is 1 meter long. And then they're telling that EA is equals to HG. EA is that upright there, is equals to HG, is equals to that line. Now, do you see, with this question, I cannot calculate the area 1 and area 2 and subtract like we did the first one. It works totally different. Now, when I look at the shaded area, I actually have two rectangles. I have this rectangle here, DEBC, and I have another smaller rectangle here, ABGH. But with this bigger rectangle, I only have one side. I need to find another side because the area of a rectangle is length times breadth. I only have the length, I don't have the breadth. Okay, now I start thinking, what can I use? When I look at this, I have a triangle here. This triangle, I can use Pythagoras to find that line EB. Do you see that? I can use Pythagoras to find EB. Okay. Right. When you look at this triangle, rectangle ABGH, it's a rectangle. So AB is equals to BG. Is opposite sides of a rectangle are equal. So it means my BG is equals to 0.2 meter. And the reason, opposite side of rectangle. the opposite sides of a rectangle are equal. So if this one AH is 0,2, this one BG is also 0,2. Why is that important? Because I want this whole line here to form a triangle for me. So do you see now this line BF is equals to, is that 1 meter plus the 0,2 here, so it's 1,2 meter. Now I can use Pythagoras. I have the whole line there, I have that line there, and I'm calculating for EB, right? So I'm gonna say the hypotenuse squared, which is 1.3 squared, is equals to EB squared plus 1.2 squared. And the reason why am I using that, I'm using Pythagoras. Right, 1.3 squared, take your calculator, say 1.3 times 1.3, you get 1.69 is equals to EB squared plus 1.2 times 1.2, you get 1.44. And then I'm going to take this, I want EB, I'm going to take this to the other side. It's going to be 1.69 minus 1.44. If I take it to the other side, it changes the sign, and then it's EB squared. Let me use my calculator. 69 minus 1.44 is equals to 0,25 is equals to EB squared. This is not your answer. Your EB still has a squared, so I have to square both sides. Then I'll get EB is equals to, I'll do the square root of 0.25 is equals to 0,5 meters. So what does it tell us? Back to the drawing. It tells us this whole line is 0,5 meters. EB is 0,5 meters. Right, we found that this whole line EB is equals to 0,5. But there's a statement there. It's telling us that EA, this one, is equals to HG, that one. So, but we know that this is a right angle, so this side is equals to that side. So if this is 0,5, we're going to divide by 2, we'll get this one and that one. So we're going to say 0,2 divided by 2, 0,5 divided by 2, and then we get 0,25. So it means this line AB is equals to 0,25 meter, which is equals to HG. So you see, this one is, we're going to call it area 1. Area 1, the smaller one, is a rectangle. So the area is length times breadth. So the length is 0,2, and the breadth, the length is like that, and the breadth is this one that you just calculated, is 0,25. So this area, the shaded area here, is 0,2 times 0,5. We get that it's 0,05 meter square. So this shaded area here is 0,05 meter square. Now I need to calculate the area of the bigger one, which we're going to call area 2, but it's also a rectangle, so it's length times breadth. The length there is 0,2, and the breadth is that whole line EB, which we calculated to be 0,5. 0,2 times 0,5, it's 1 meter square. So in this question, the shaded area is equals to 0,05 plus 1 meter, which is equals to 1,05 meter square. So the shaded area, this whole part, this whole shaded area is 1,05 meter square. So I did these two examples to show you that you have to look at the question paper, read it properly, and see that you can calculate. You have to use different methods to calculate them. This is the end of our lesson. Thank you for watching.